Hello, and welcome to video number 3. So I just went and grabbed the detectors that we had sitting over by the window. Here they are here. They've been running for 1 hour and 14 minutes. Okay, and the slave detector, which is the bottom, it sees a count rate of 0.158. Okay, plus or minus 0.006. Okay. So it's slightly actually lower than I was expecting. I was expecting about 0.17, but that's only about 1.5 sigma off. But what I'm going to do is I'll take this and run it downstairs at the end of this video, let it sit there for about an hour. Then while I'm making the final video, the 4th video, I'll bring it up and we'll compare it to the 0.158 count rate that we see here. And I'm guessing it'll probably be about a maybe 25% rate change or so. Okay, so we'll see. We'll see once we get the detector back. So in the previous video, we built the main PCB and we verified that at least the voltage going to the SiPM is correct. So I'm comfortable plugging a SiPM PCB into this guy. What we're going to be doing right now is we're going to be building the SiPM PCB. So here's the components here. So the first thing we're going to do is we're going to start off by populating the SiPM PCB. Okay, and there's actually 2 independent components to this piece. So we have some 49.9 ohm resistors, and some 10 nanofarad capacitors. So on the right hand here, it's the components that are connected basically to the cathode of the SiPM, and it's what's providing the biasing voltage to the SiPM. So these components that I'm putting on here on the right side, and these capacitors indicated here, these are actually just low-pass filters. On the other side, so this is the anode side of the SiPM. The anode side contains a single resistor, and this resistor is just to hold the line at ground when there is no pulse. Okay, so my resistors look like they're in place. And let's just put on the capacitors, the 10 nanofarad capacitors. There's 4 of them. Okay, so my capacitors are poorly in place, but I'll just clean those up real quick. Okay. So surface mount components are done. Next up, we have a 6-pin connector. So this is the, let's see if we can see it. This is the connector that plugs into the main PCB. And you want to align this relatively well. You can imagine, since there is also those aluminum hex standoffs, since those fit into holes on the main PCB, you want everything to line up properly. Oops. Okay, that looks pretty good to me. Okay, and the final component on the back here is these hex standoffs. So let me just grab 2 of those. And 2 pins. So you can see they fit into the middle holes here. You'll see when I do them. Okay. And what we'll do is we'll actually give it just sort of a quarter turn to make sure that it's tight. So I just take a crescent wrench, hold it in place, and we'll just torque it a little bit from the other side. You want this side to be nice and tight. You don't want to be able to undo this by hand. Okay, so there's the main PCB. Okay, the only thing that's missing at this point is the SiPM, which is the funnest component because it's by far the most expensive component of this project. It actually represents about half the cost of the whole project, is this little guy here. So do not use tweezers when dealing with the SiPM because the actual acrylic coating on the SiPM is relatively fragile and you don't want to scratch it. So there's my SiPM, and there is a direction on it, obviously. The way that you identify the direction is, you're not going to be able to see this on my camera. My camera looks like it's pretty poor quality. Is around the edges of the SiPM, there's these little pins that stick out, and one of the sides has an extra pin. So every corner is symmetric except for one, and the one that's not symmetric is the one that's labeled number one, or pin number 1. And again, on my silk screen, you can see that pin number 1 always comes with some sort of circle, so you can see a little circle there. So let me just put a little solder onto one of my pins to get started, line up my SiPM in the correct orientation, figure out which one's number 1. Yeah, it's even difficult for me to see. Okay, so that's the orientation that I know it has to go in. And the way that I'm going to do the SiPM is I put a little bit of solder onto the single pin. Then I'm going to move the SiPM in place and just hold it in place with my finger, kind of sitting on top of the solder that I just put there. When I'm sure that it's lined up properly, you can gauge how well it's lined up with the silk screen. My silk screen gives an outline of it. Then I'll hit it with some heat and it'll just fall down to the board. I'll let it cool and hopefully it'll just land in place. Now you don't want to apply too much heat to this. It's relatively quick. So there, so it's in place now. I know the SiPM, so if it was to fall down to the board right now, I think it would be in a good spot. As soon as I hit it with heat, it goes down to the board. That's it, let it cool. And then I can check how it actually looks, and I think that looks fine. So now the SiPM is in place, and the way that it should be is the SiPM should take up about one quadrant of the actual footprint, or the pad on the footprint, sorry. Okay, and once I'm comfortable with the position, which it looks okay, I'm sure this one will work. I'm not too concerned about this one. Yeah, I just put a bit more solder onto the other side. Solder's not very good. And then I can touch up the first side again. Okay. There. So I'm pretty confident that this guy is good. It's not the best one that I've ever put in place, but some things that you want to observe is you want to make sure that it's completely flat against the board. We're going to be putting pressure on this, right? The scintillator is going to sit on top and we're going to put some pressure on it. So you don't want it to be raised against the board or you could potentially crack it. You also want the screen to be nice and clean, which it is, even though I touched it with my fingers. You can clean it off with some acetone if you even like, or ethanol perhaps. I use acetone. But this one looks fine to me, so I'm not going to worry about it. If we want to check to see if the SiPM is correctly connected, we can do this basically by, we can't really test the SiPM without wrapping it up, making it light tight, and putting some voltage across it. But we can see whether or not the pins are actually connected using some neat kind of sort of trick. So the SiPM is going to act sort of as a diode. In one direction, current can flow, and in the given if there's some light on it, and in the other direction, you should see basically just absolutely no current. So what I'm going to do, I can do it on this side. I'd like you to be able to see the multimeter here, except the polarized screen looks like it's causing problems. Let me see here. I think that's okay. I think you'll be able to see the readings once I So I'm going to set it to the, I'm going to just measure the resistance, basically. Yeah, sorry, the polarized screen kind of wrecks this. So what I'm going to measure is I want to see, I'm going to measure across the SiPM from, I'm only connecting pin 1 and 3. And in one direction there should be infinity resistance, or infinite resistance, sorry. And then the other direction I just swap hands. There should be some finite amount. So it's actually easier to do it on the back side, so I'm just going to flip it over here. I don't want to crush the SiPM, so I'm just putting it on top of these things here. And I'm just going to measure across the direction. So what do we see here? If I measure this direction, it's some finite number, right? You can see something's happening, right? It's kind of all over the place, but there's some finite number. Okay, and then we switch hands. And it should be infinity. Oh, sorry. In here, sorry, I had it backwards. So here's some finite number. Or sorry, yeah, here's some finite number. If there's a lot of light, basically you see the multimeter jumping around like that. So there's quite a bit of light here. If I was to remove some of the light, say by, I don't want to crush the SiPM or damage the surface, but let's just see here. Let me put it on here. So this will block out quite a bit of the light. You should see some finite number or something. Yeah, so let's like get it in the right direction. Yeah, so it says like 10 mega ohms or so. So one direction sees some current, one direction did not see current. Did I do that correctly? Yeah, so there's nothing. Swap hands. And there's something. And so what that tells me is that it tells me that the actual pins on the SiPM are connected, and I'm comfortable going forward and doing the painful part of the project, which is actually mounting or taping it up, basically. The tape, making it light tight, it's kind of time consuming and boring. But I'll skip over. I'll show you how to get it started and I'll just skip over it. Okay, so this guy's done. Now let's start on the SiPM. Or the Scintillator, sorry. So here's my piece of Scintillator. So I machined this in the shop, and the way that I machined it is it came in an extruded slab like a meter long. I took it on the bandsaw and I just cut it into, let's say maybe 52 millimeters this direction. Then I put it on the mill, and with a 1/2 inch end mill, I just brought it down to exactly 5 centimeters in this direction here. And so this is the face surface. You can see it's not particularly opaque, but we can improve that. So the way that we're going to make this a bit better is we're actually just going to put some heat on it, and it'll melt it, and then when it solidifies, you'll end up with a nice clear face. So what I'm going to do is I'm going to turn on my heat gun, and I'm just going to hit it with some heat, and you can see what it looks like. So just give it a second to heat up. Here's my heat gun. Now I don't have quite a large airflow here, but it's really hot. I have it set to pretty much the maximum temperature, and air just barely blowing out. And then when I touch it to the surface, so this is, if you can see, it kind of looks kind of murky. Let's go back and forth, and you should be able to see it clear right up. Now you want to make sure that you do all your machining before heat polishing this. So, for example, these holes here, they have to be drilled before you heat polish it. And the location of those holes can be found on, we have a CAD drawing on the GitHub account of where those holes are located. The problem with heat polishing and then machining is it changes the crystalline structure of the Scintillator and it'll crack. So if I was to touch this on a machine afterwards, it would just shatter. Okay, so one side's done, and I'll just do the back side here. Okay, whatever, that looks pretty good. So now the actual Scintillator is much more transparent, and it'll improve the collection efficiency on the actual SiPM. Okay, so there's my Scintillator. And for fun, I can shine a little light on it. You can see it light up. Okay. So now what I would do is I would mount this, or I'd start wrapping it up with the tin foil and leave a little area free for the SiPM to go in. But before that, one thing that I think is kind of useful is to show you what it would look like without the tin foil. So here it is. We're at the same step. The only thing that I've done is I took our number 0 screws and I screwed them into the scintillator through these 4 holes here. I've also put a little bit of optical gel, so I can show you what the gel looks like, onto the face of the SiPM. So here's my SiPM. I have a little piece of plastic in here that just has some optical gel, so there's some optical gel. And I just put a little bit on the surface, sub-millimeter for sure, just enough to cover the surface. Once you put pressure on this, it'll flow outwards, and bubbles will slowly escape. So if you have any bubbles in between the interface, it'll move out. And then basically I mount this on there and screw it in place, and it'll look something like this. So what I'm going to do now is forget about this. What I'm going to do is I'm going to actually wrap the scintillator. But the first thing I need is I need a little piece of tape. Let me just get that out real quick. I would say that the taping job is relatively important. You know, you want to make sure you're taping this so that it remains light tight. If you do a good job, you won't run into any problems later on in the future. I've had some of these detectors running for maybe half a year now without any light leaks, but you just want to make sure that you're doing a good job when you do it. Okay, so here's my piece of tin foil. Put the scintillator in place, and we'll just wrap it. And what you're concerned about is you don't want the tin foil touching. The tin foil can touch any of this metal fill here. It just cannot touch the SiPM legs. Okay, so that looks a bit tight to me, so I'm just going to maybe trim off. Oops, maybe trim off 3 millimeters from either side. Make a mess in my office. You want to try and avoid crinkling the tin foil as well. So something like that. Okay, looks pretty good. And we can start wrapping. Something like that looks pretty good. And then we'll take a half piece of tape. Tape it in place. Yeah, looking okay. And make sure the other side's tight. Like something like that, and tape that in place as well. Okay. There. Looks good. You can see the nice purple glow. Okay, so now I have some optical gel on there that's going to fit inside this little opening here. The only thing that needs to line up is there's these holes, these 4 holes here. If I just put a lot of pressure onto the tape, the holes kind of stick through. I don't know if we can see a reflection. Yeah, you can kind of see the hole there sticking through. I'm just going to poke that. And another one. And once you have 2 of the holes lined up, the other ones will automatically be lined up. Okay, so then we need some screws. So I have some little number 0 screws here. I don't know where my other ones are. Normally I think I use 5/16 screws for this, but I don't know where my container is. It's probably downstairs. So I'm using, I think these are a 1/4 inch. Alright. Line them up with the holes that I just poked through the scintillator. Screw in place. And the important part here is you don't want to screw it all the way down. The PC, remember there's a SiPM underneath there, and the SiPM is about maybe 0.5 millimeter to 1 millimeter thick. So there's going to be some gap between the PCB and your tinfoil. But you want to bring it down so that's nice and tight, and all of the heads of the screws rest in place and hold the PCB in place. Over tightening can break the pins on the SiPM. Okay. And when I look around, I don't know if we can see this, but looking around the edge of the PCB, there's about 1 millimeter gap all the way around. Okay, so this guy's done. The next part is just to apply some black tape all the way around it. So I wrap black tape one way all the way around, then I run black tape the other way. And I try and do a really good job in it. I'm not going to do that because it takes about 10 minutes to do, and it's kind of a boring thing to watch, but I can show you what a finished one looks like. I don't know if I've tested this guy. No, I don't think I tested that one, but I think I tested this one. So here's what a final one would look like. Okay. And I've tested this, so I know it works. So we should just be able to plug it into our detector. And it should just work right off the bat. So let me just bend the LED down. You know what, I actually have to upload new code to this detector as well. So this is the one that we built. It's running kind of older software right now. Let me just quickly upload some new code. The way that we upload code is we basically just plug it into a computer, and then using the Arduino IDE, we have our code available in the GitHub account. Hopefully, we'll be able to put out a video later on. One of our collaborators, Cassius, she'll be able to give an overview of how to actually use the code. So you can see it's going crazy right now, but just give it a second. It's probably because the threshold is set too low for whatever code I just uploaded to it. This guy looks okay. And it probably takes about 20 seconds to upload. Oh, I did forget one component on the bottom, which I just realized. So let me just quickly add that to it as well. Okay, it's not an important thing. It's the component that I'm missing actually will just improve the ADC, the quality of the ADC readout. But you can see the detector's working. So you see blinks every second or so. This is a good indication that I don't have a light leak here. It's a good indication that my circuit is doing okay. The component that I'm missing is not a big deal. It's a resistor that just goes to ground. I'll fix that up now. I don't have wire with me. But now that the detector is going, and I'm confident this guy was designed built properly and had all the correct components, and I've seen a count rate that wasn't absurd to me, I'm comfortable in claiming that this guy is good. So in the next video, what I'll do is I'll take this detector. I'm just going to put on the resistor right now. I have to head downstairs to get some wire. We'll plug it into scope, okay, and I'll show you how to troubleshoot the individual parts of the detector. I'll also take the setup of I'll take these guys downstairs and just put them in the basement for an hour, grab lunch, come back, and then we'll test this guy, and I'll show you what the reading downstairs is. Okay, see you in the next video.